Welcome back to the DISCUS program channel here on YouTube. This is Reinhard Meder, and I'd like to guide you in this clip to the user interface that comes with DISCUS. As usual, if you want to follow along, I've prepared some presentations and a set of instructions in lectures. These you will find here on our homepage and on my office at www.icSP.nat@fau.eu/neda-group/discus-supplements. There you will find the link to the presentations and to the lecture little instructions for the DISCUS program. Download these and unzip them into a suitable folder. For example, I've placed them here into Documents /Discus Workshop. And you see I've unpacked them on the top here. You see in the Windows Explorer, the file in Documents, DISCUS Workshop, Lectures. And right now I'm in part of 00 Introduction, since we're still at the introduction into the program. If we start the program, you need to double-click the DISCUS Suite icon, as usual for most Windows programs, and then you will eventually get the interface here that is presented on the screen. And in contrast to most other programs, the DISCUS program does not have a graphical user interface. The reason behind that is the program was written and is still maintained to be able to simulate disordered crystal structures with lots of defects, and these defects and the disordered structures, they just simply don't come in a very straightforward, repeatable manner, and thus you need very much flexibility to build these structures. Any kind of disordered particle, disordered nanoparticle or crystal structure will be different, and so you will need a different approach to that. And to keep this flexibility, that is much easier with this command language like userface to the DISCUS program. Some of you may have been familiar with programming languages, for example Python, that is fairly popular these days. Think of the command language in DISCUS something like a programming language, except in contrast to Python, this was invented some 30 years ago when I started the DISCUS program. So with that, let's start. In your Explorer here, navigate to the folder in the Lectures folder to 00 Introduction. We'll use that at the beginning for our guidance. And what you should then, if you start the program, see on the screen, similar to what I have here on the left-hand side, the usual interface by the DISCUS program. And the first thing you need to do is, you see here the prompt, it says DISCUS Suite, just simply, and you are asked to then type instructions. The first instruction you typically will want to type is a CD, that stands for Change Directory, in order to change to a folder. So if I do this here on the fly, I type CD with a space and no enter, no return yet. Instead, what I need to do is I need to left click here on the little icon in my Explorer. So if I activate that, left click here on the icon on the top, you see the whole string turns blue and gives you the full complete path. You can copy that with a Control-C, and then you can paste that once you've activated the DISCUS window again by a Control, Shift, and the middle mouse button. That will paste this into the window. I need to correct that here in my guides, so it should be Control, Shift, and the middle mouse button to guide that in there. And now, if I do that, see here I've corrected it, Control, Shift, V or Control Shift middle mouse button, both works, similar to the Control-C, Control-V you may be used to, except that you have to add here the Shift button to go into capital letters. And then you have pasted the string to the full path to the folder into the DISCUS window, and after return you will then get this screen that I have already on the left where you're in the current working directory. And now you can use this folder to have your data on disordered nanoparticles or disordered crystal structures to work with and to build a model structure to refine against your little particles. If I continue here on the presentation, another alternative is to go with a cd command. You can go, as I typed on the next screen I will do, to any kind of directory. Typically what you can type is there's a command called system, and this system command allows you to start any kind of shell program, any kind of command program, particularly if here, for example, pwd, it's a Unix name that stands for present working directory, and that tells you in which directory are we currently. What I've explained here in the presentation is that when you start the program, and if you type system pwd, you will see you end up currently in the directory C users and then your username. Ignore the /mount. That's due to the fact that the program is actually a Unix program and runs on a Unix behind your Windows. I might eventually mask that in a new version. Forget about that. But basically you end up in users and then your username, and from there you can navigate to any kind of path with the command cd, and then you can type the path to a new folder, either as an absolute path starting with C /users, etc., or by a relative path. For example, if I want to go up a directory level, I simply type cd and then 2 dots. And if I hit now the enter key, I end up not in the lectures/00 introduction, but in the folder DISCUS workshop lectures, one parent folder about it. Notice that in the DISCUS program you will see here the divider between folder levels as a slash rather than the usual you might be used to Windows /. It will operate with both of them, slash or /. DISCUS doesn't make a difference there. It'll notice the difference. All right, let's get to the main programs commands that you have. See, if you type here a simple enter, nothing will happen to the program. The commands just shift up. And one of the first commands you might need to use is the command called help. And this enters a help menu. Alternatively, if you know the name of a command, you can type help command. Let me do this here right now real quick. If I simply type help, we get at the help level here of the DISCUS suite, which is the top level of the program. And you see there's a small short guide to what you can do at this help level, a little introduction, what this command is all about. And you typically have then on the bottom here a list of further commands that are available at this level, which you can go into. So if I, for example, if I type now simply DISCUS, then we get here to the help on the DISCUS level, and you see the DISCUS command at the suite level will switch to the actual DISCUS section. The DISCUS section within the DISCUS program is the one to build crystal structures, to introduce defects and disorder into these. In order to get out of the help, you simply have to type an empty space. So you're back here now at the regular DISCUS suite prompt. So you could all likewise have typed help DISCUS, and then you would get directly to this last help entry that we had on the details of the DISCUS command. Notice you don't get the full list of all the options here automatically. Simply type a question mark here at this prompt, and then you will get the list of all the possible help topics available. One help that we may get to in a little while is here the command language. This gives you the details of all the commands that is common to my sections in the program. In the program you have sections like DISCUS, the structure builder, diff-ev, and as of version 6.0, the refined section, Both sections allow you to refine a model against experimental data. And then there's the cuplot section, a graphic section, a section to appraise data, to compare data to experimental values. Another important command, of course, is at some point or other you might want to leave the program. On a Unix program, what you typically have to type is simply exit. On Windows, alternatively, you can, of course, simply close here the total window and everything will be closed. But keep in mind, if you type exit, the program will assume that you know what you're doing. So if you type exit, then the DISCUS suite is finished. Even if you have built an extensive structure that you haven't saved yet, all that work will be lost. So keep in mind, be careful with these commands. DISCUS assumes you know what you're doing, and that's what you want to do. So let me restart my program here. And then we quickly go here. Let me show you how to do it with the extra command, since I'm right now in the folder here, users slash, this is actually account H, not Reinhard, doesn't matter. But if I go to the CD documents, I don't have to type the full name. If you hit the tabulator key, it'll expand the folder name, DISCUS. Here you notice I have several folders that start with DISCUS, so DISCUS Workshop, Lectures, Ops, and there we have a little error. It's okay to have an error here right now. The command language has been written such that it should catch most of the errors that you type. And here the error is, of course, I have a CD and then type the CD again. So we don't want that. But this is a good chance to introduce the ability to do command line editing. So you could use the arrow up and down key on your keyboard to retrieve previous commands. And then you can use the arrow left and right key to migrate through that. Or if it's a lengthy command, simply type pos1 to get to the beginning of this command. Now we go a little here to the right and use the backspace key to erase the first CD, so we are just left with one single CD. I don't have to migrate all the way to the end of it. In order to accept the command, you simply hit an enter as that level as it is. Alternatively, of course, if you need to add something to the end of the command, you can type the end key on your keyboard and the cursor will jump to the end of the current line, and then with a simple enter you will get to activate this command. This last space at the end of this line is not necessary. I just did that to make it more readable with a black cursor to be off my text. Now we're in the folder DISCUS Lectures. So now let's go to the folder 00 and the tabulator key expands it to Introduction. And we're now in the right key where we want it to be. So let me activate my presentation again here. And the next thing that one often uses, rather than to type these commands interactively, so 99.59 or so % of the time, I will actually not type the commands interactively, but I will type these commands into a small, simple text file, a macro we call it, and this macro file contains the commands as if you had typed them manually, and with the @ sign in front of it, that will instruct the thing to do. Here's a small macro that I built earlier called macro.mac. So what I can do is, if I type the @ command and then macro.mac, again with the tabulator keys that can be expanded to a full name, now this will run the actual commands as if printed in the command. Let me show you system cat, another Unix command for catalog, to show you the content of this macro. There you see the full content of the macro. It starts with some commands that I want to skip. Mostly what we saw is here this echo command with the echo up on the top here that you saw displayed on the screen. So all the content that is typed inside such a macro file will be executed as if you had typed it. And that makes it easier to repeat a task, to do it over again. You don't have to type that many commands, and you can build your own library of macros. Actually, in this folder lectures, you will find plenty of different subfolders which all contain many of these macro files with templates that you can use and expand upon. So another command, rather than to type them using your favorite editing program, is a command called learn. So we could type here learn new.mac, and now anything that I type from now on will be copied into this macro file, including any typing errors. So we'll just keep it short and we'll type here simply echo hello, my first macro. And now, as explained here, the lend command, a 4-letter command, short abbreviation for end the learning process, stops the learning process, and then will store the data in our macro called new.mac in the current folder. So let me do that. lend. And now the macro is finished. You will see that I have now here this macro new.mac, which I could open in an editor. And you see all it contains is a simple one-line text here, echo space hello my first macro. And if I now run this macro with the @ new, and I'm lazy, so let's hit the tabulator key, new.mac. Now we get the prompt there, the information, hello, my first macro. Nothing special, but just to show you the basic idea how that works. Another important command is here the manual command. That will give you, alternatively to the online help, a bit of background, the manual that comes with the program. And you can open it either simply as manual or in the form manual and then section : the name of the sections, where the sections are either suite, DISCUS, DIFIV, cuplot, refine, or the package. So if you just simply type here manual, a PDF viewer will open up. Ignore the error messages there. Right now this is the user's guide to the version 5.99, soon version 6.00. And if you go through there, you see here the table of content of the DISCUS Suite manual. And inside I've put in at several points here, for example, a link to other help documents, other manuals. For example, here we would go and open the DISCUS manual. Let me go back to see that. If you here click on this DISCUS, it'll go to the first page in the actual DISCUS manual with a PDF file viewer that I've opened. It opens up a new tab inside, and there you have then the more detailed instructions to the DISCUS sections. Likewise for the DIFIV, refine, cuplot, and here the package manual that describes all the commands in the command language that is common to all the different sections. Due to the error messages that I need to get rid of here, simply type another return to get back to the DISCUS Suite. And that is a lot of information that you can find in these manuals, example described about the program, things like that. In general, you've seen it already, the syntax of any kind of DISCUS command is either just a simple command, like we had the help. We might type an echo here. If we type simply help without any further parameters, we get into this help menu. Similar, if I type here DISCUS without any further parameters, I then get to the DISCUS section of the program that you can recognize by the changed prompt that now says DISCUS here rather than Suite. With an exit, I get back to the top DISCUS Suite again. So just simply a command without any command name. Notice Most of the commands can be abbreviated as long as their name is unique. So instead of typing DISCUS as a full name, I could have typed DISC or DIS even to get to the DISCUS section. Often it helps if you want to interactively type something that you don't have to type the full name. Inside a macro, I would rather recommend to use the full name. Makes it easier to not make an error and know what you're talking about. Many of the commands take one or more parameters to give you more details on this command. And the syntax is that after the command, you have to have one space here. You could use a tabulator as well, but I usually prefer just an empty space between the command and the parameter. And then you have a list of parameters, sometimes just one parameter, sometimes several parameters. And all these parameters are separated from each other mandatorily by a comma. So for example, here this command, evaluate 4 plus 5. If I do something similar to here, eval is enough, don't have to type the full name. 5 plus 6, we get of course 11. So this evaluate command simply calculates a numerical expression and displays the information on the screen. The insert command that I have here as an example is within the DISCUS section and would insert a silicon atom at coordinates 0, 0, 0 with an atomic displacement parameter of 1.0. But all these parameters, commands, have a name, possibly abbreviated, a space, and then some parameters that these commands may or may not need. You can, let me click through that here, put somewhere in a line a hashtag or an exclamation mark. Both work equally well. And anything to the right of these is a comment. So you can type, especially in a macro, comments in there. So if you do here 5 plus 6, the string here to the right of the exclamation mark is now treated as a comment and not taken into account in the actual evaluation of the command. The command language is really a subset of a computing language, a programming language, of the Fortran language, and as such, the command language has the options to have variables. Here, in variable there we can store integer numbers, whole numbers, another variable where you can store real valued numbers, decimal numbers with a fraction behind the decimal point. There's also, not explained here right now, character variables that you can use to store alphabetic strings in there. You see the I has a square bracket with an index going from 0 to 500. You can store in there 501 different integer numbers. Likewise here for the real valued array, where you can store any kind of number in the entries 0 to 500. That gives you lots of different things. Now I quickly find it difficult to memorize what the entry R, let's say 354, is all about. So instead, DISCUS allows you to build your own variable names, and therefore you have a command called variable to do this, a qualifier that types the type of variable. Is this a real valued number, like here 3.1415, or is it an integer number, a whole number that is restricted to values like 1, 2, 3, and so on. So as a demonstration here, if we type variable real, comma, we can type here variable real Euler and say the 2.7, rather rough, excuse me, of course we need to say 2.7 equal 2.7 there, and now this number would be stored as 2.7. not super accurate, doesn't matter, in there. Likewise, I can say here variable integer, comma, number, for example, and then say number is equal to 55. If I evaluate that, you will see it's displayed on screen as a decimal number with fractional coordinates, which are all 0. But it just was simpler in the programming to include the decimal points. But notice if I say here, number is equal to 55.3 or 55.4, if we then display its value, it is still exactly 55. So the number is truncated down to the next smallest integer that would be there. Proper representation. So with the I0 to 500 or the IR0 to 500, you can store many different numbers. Likewise with these variables, you can define your own variable that could contain something. I haven't described it here in the presentation, but you can also say variable real, comma, let's call it vector, comma, and then you need the instructions dimension, for example 3. This would create or will create a vector with 3 dimensions, and we can then say vector, and the elements of these variables are to be used with square brackets. So this would be 1.0, for example, and the second element 2, and then not to make it too simple, we say here minus 0.5, why not? And now the elements of the vector will be values 1, 2, and minus 0.5 along the third entry, the third dimensions in this vector. Similarly, we can define variable real, comma, let's call it a matrix, comma, dimension 3, 3. And now we will have a 3 by 3 matrix whose elements we can populate and use. DISCUS, as the other sections as well, has its own set of variables. For example, in the DISCUS section, there's a variable called n, entry 1, 2, actually all the way up to 7, and they contain specific information to this section. For example, the variable n in DISCUS, n, the entry 1, is the total number of atoms in your crystal, n of 2 is the number of different atom types, and so on. Likewise here, x, y, z with square brackets, and then an index would be the x, y, z coordinates of an atom in your crystal structure. And the other sections of the program have their own variables, their own specific variables for their purposes. All right. As you might have seen already, you can use these variables and in general expressions here for any kind of mathematical arithmetic expressions. For example, here you can assign a value of 3 to this integer value, or here use an old value that was placed into I0, add to that 2 to the power of 4. Here I use the Fortran style. 2 with 2 stars is an exponentiation. Likewise here for decimal numbers, notice here, we'll get to that a little more in detail later on, a function cosine of an argument is calculated, etc., etc. And then you can evaluate these, assign data to that, or here use brackets to change the usual hierarchy of symbols. As usual, the brackets have highest priority, then functions within a bracket or a level at one hierarchy level. You have then exponentiations first, multiplications, divisions next, and additions afterwards on subtractions. All right, time for a little homework. We want to start a learn process that will build a new macro called homework1.mac. And the task of this macro shall be to define an integer valued variable, let's call it product. And into this product, we want to store the result of the product of the numbers 1 times 2 times 3 times 4 times 5. And then we want to evaluate the result of this variable, stop the learning process, and then execute the macro to run that. So to execute this macro, once you finish the learn process, you would type here at the prompt of the suite or DISCUS, doesn't really matter, the @ homework1. Notice you do not have to type the full name.mac. DISCUS will actually search on your disk. If it finds not the file that is called homework1 without extension, it'll automatically look for something .mac in there. So I give you a few minutes to run that by yourself. You might want to stop this macro, think about it. How do you build such a little macro? How do you store the variable? Go through the previous slides, rewind the clip a little bit and check that. All right, I hope you didn't cheat and didn't just follow me doing this here. In order to do this homework, what we would have to do is first, we need to define this variable, an integer variable. So that's command is called variable, and the type of this shall be an integer. And now we will call this variable product. Be very careful that you have to always type everything very accurately as typed, or else you will get an error message. But here, for example, we have to type the full name variable integer. The spaces here, the extra spaces, are irrelevant. Now we have defined this variable, and now we want to store into this variable the result of the product of the numbers 1 to 5. So we could say product is equal to 1 times 2 times 3 times 4 times 5. Again, the empty spaces are just to make it easier to read. Voila, now we've done that. Evaluate product. And I give you a moment to estimate what that should be. It should, of course, be 120. And we see, yes, the value of the product is 120. And now we need to stop this learn process. So we simply type lend followed by an enter. All right. What I forgot is simply to start the learning process. So we simply do this again. Learn homework1.mac. And I don't have to retype all the commands. I can simply use the readline capabilities to go back here, define the variable, populate its value again, evaluate the product, and now type lend. And now the macro has been finished. Again, this is a little reminder. If you type a typing error in an evaluation or a calculation or use the wrong command, DISCUS usually tries to give you here some error message in red that gives you more or less lengthy explanation as to what might be wrong in the command in the type that you have typed. So let's test if the macro does work. If I type @homework1.mac, again I use the tabulator key to expand the full file name. If I type now enter, you see all the commands that are inside the macro are displayed here on screen, and at the end we find here the value of the product equal to 120. And that would be a typical use of macros inside DISCUS, that you store more or less lengthy calculations to build a crystal structure, to introduce disorder, to modify that, and do this task again, maybe as a template for later more complex structures to be built. All right, so you see here the solution reflects what I typed, variable integer product, and then product equal 1, 2, 2 times 3 times 4 times 5, and then we evaluate the product to get the details. As the next step, the command language has built-in functions, intrinsic function that are commonly used. So we have here the trigonometric functions calculating the sine, cosine, tangent of an argument, and I choose to use a function called sine if the argument is in radian, and the function is called sine with an extra d here, sine d, if the argument is to be interpreted in degrees rather than radian. And the inverse functions are called a sine, a cosine, etc. Also again with a d here if you want to have the result now in degrees. Then there's a square root function that calculates the square root of the argument. Let me show you that quickly here. If we do evaluate square root of 4, we get, of course, 2.0. At the moment, if we type here square root of minus 4, you will get an error message, since at the moment I have no complex numbers in there, so it just simply tells you that you have a square root of a negative number. And then there's an exponentiation, e to the power of something, a natural logarithm, an absolute value, stripping the minus sign of a number if it has one. And if you type conversion functions going from a real valued argument to the integer, and you see this goes from 1.6 towards 0 to 1. The next int function goes rather from 1.6 to 2 to the next nearest integer number. The opposite of that would be the frac command that will give you the fractional part here of 1.6 will give you 0.6. And then there's a min, likewise maximum function of 2 arguments, returns the minimum maximum value of these. Every once in a while one needs a modulo function which will give you the rest after the argument 1 has been divided by this, and so you would have the integer division there, the argument 1 minus the integer of argument 1 divided by argument 2 to give you that. So for example, the modulo of an odd number, comma 2 would always be 1, and so on. Very helpful in the building of disordered structures are my random number generators. There is a even uniform random number generator that will return a value between 0 included and 1 excluded, a Gaussian distributed random number generator that will give you numbers symmetrically around 0. The width of the distribution is determined by arc, which is the sigma of this distribution, and you can describe Gaussian distributed random number around a mean value of 0. Similarly, there's a log normal distribution with 2 arguments, the mean value and the sigma of the distribution of the underlying Gaussian distribution, and a Poisson type distribution where arc would be the maximum value of the counting rate of a counter. In order to build flexible macros, DISCUS comes in its command language and its programming language with 2 control concepts. The first are conditional statements, and all of these conditional statements have basically a syntax: if, and then in round brackets a condition, the keyword then, and then a block of instructions which will be executed if and only if the condition here is true. Optionally, you can add an else if block if the first condition was not true, else if the second condition is true, then the second block will be executed, and so on and so on and so on for many, many, many blocks. And then finally, you may add an else block if all the conditions up here were false. Finally, this block 3 will be executed. If the block 3 with this else is omitted, you may end up with none of these statements executed depending on the value of these conditions. The conditions are typically an expression with an operator and again a numerical expression. So for example, here I have an expression down here. If 3.14 is larger than the arcsign of a value, that would be a typical expression there, where the operators are either a less than sign, less or equal, equal, greater than, or greater, equal, and greater than. And you can combine several of these operators with and, or, not, or also an XOR, an exclusive OR. As in this example down here, you can type if 3.14 is larger than the arcsign of a value, or if the content in variable is equal to 0, then do something. And that's commonly done in order to do something. For example, if you have in your crystal structure a certain atom of, let's say, silicon type, you might want to do something to this atom. Alternatively, it's an aluminum atom, you want to do something else to these atoms. Often one wants to do things repeatedly, and DISCUS comes with 3 different types of loops to do this. If you're familiar with C or Python, these would be equivalent to a for loop in those command languages. And the first form of this is the word do, a counter variable that is equal to a start value, end value, and optionally an increment, which defaults to 1, a block of commands that's executed until we get here to this end do statement that signals the end of this loop. Alternatively, in this loop here, you would always run this with a fixed number of cycles. I'll show you an example in a second. Sometimes you want to do loops until you meet a certain condition, and that you can do with either this condition here, do while a logical condition, and then this block 2 will be executed while this logical condition is true, possibly forever. Alternatively, you can do here a do, a block of statements, and an end do until this condition. The difference between these two is simply that here, if the initial condition is false, the block may never be executed. While down here, the block is always executed at least once, since you test at the end of the block whether you want to do this or not. An example, a very simple example here would be do. Let's use the variable I entry 0 as the counter variable, and that shall go from 1 to 10 in steps of 1. And then in the loop, we do nothing but evaluate the current counter and we'll show you the display on the results. Let me do this here in the demonstration. So I type do I of 0 equal 1, 10, 1. Again, space is just for readability. Notice the prompt changes. It says now suite/do to tell you you're inside a do construction so that you don't forget the corresponding end do statement. Evaluate I of 0. And if you then type end do, voila, we're now counting from 1 to 10 here. Nothing exciting. And something like that would typically be enclosed inside a macro where you want to do a little more flexibility. So alternatively, the same stuff you can do if initially we set I of 0 to 1, and then while I of 0 is less than 11, we evaluate the current value of I of 0, and then, very important, don't forget that, we increment or somehow change the value of I of 0, so that at some point or other, as we increment I of 0, this first initial condition here will be false, and then we finish the loop. Let me do this here. It's a little more typing here. Do while I of 0. Let me go back. I forgot to set I of 0 back to 0. Let's do it 1. And now do while I of, oops, excuse me, needs to be round brackets, I of 0 less than 11. We say evaluate I of 0. And now the incrementing I of 0 is set to the current value of I of 0 plus a 1. And then we do end do, and we get the same block as previously with a fixed loop here going again from 1 to 10. If you want to have a little more flexibility, that's where macros come in helpful. And inside a macro, we could write this complete text here. We could define a counter variable. We could then have a starting variable, a finish variable, and then say the counter shall be start to finish. Evaluate the counter variable, end do. And then if we do run this macro with the add loop, we will get something similar. Here on this lecture, I do have a macro to that effect. So if I edit that here, let me make this a little bigger. All right. So we have here a variable integer start, a variable integer finish, a variable integer loop. I set the start to 1, the finish to $1. This is already a little more flexible than the macro that you have there on the screen before. $1 is actually a placeholder for a parameter that I enter to a macro. And then I can run this macro here as do loop equals start, comma, finish. And we give here a little more intricate information than the evaluate of the counter at this current level. So if I run this macro here, let me show it a little more and bigger. Again, the content of this variable simply here, the start variable, a finish variable, a loop. By default, I use an increment of 1 here. So we have the start 1. We finish to a value of $1, which will be the parameter here, as explained here currently on the screen. So you can say either if we modify this here to $, then these dollars are placeholders that place something inside a macro. Let me show you here. If I run this macro as add loop.mac, now let's say 10 for example, we get the same counting before at the index here 1 to 10. And notice in the macro it said here finish equal $1. That's the string up here in the macro. And the $1 has now been replaced by this first parameter on my macro line. And that is a general rule that if you have inside a macro somewhere a string $1, $2, $3, etc., they will be replaced by the parameters provided on the add macro name line. Again, parameter 1, comma, you would need to add parameter 2, parameter 3, etc. in there as well. A little hidden, there's also a parameter 0, and that is simply the number of parameters that were on the command line when the macro was started. So let me do the flexibility here. If I type macro 5, for example, then we will run this index only from 1 to 5. And since the start value here is 1, you might wonder what starts if I type here minus 6 or some other negative value. Well, in that case, if I go back here to my macro, the loop will start from start, which is currently a 1, incrementing in the positive direction since the increment is omitted, up to the finish. And since the finish is already smaller than the starting value in this particular case, nothing will happen, and we just simply get the content of the macro displayed here once, and that's it, and that's the end of it. To show you something that you should quickly look at, but please immediately forget and never do, you can type a macro that is called evaluate $1 in round brackets $2. And if you start this macro with the first argument, the first parameter, cos d, the second argument 10, this macro here will then evaluate cos 1 is replaced string-wise by cos 1, while $2 is replaced by the number 10, and the macro will evaluate the cosine of 10 degrees. If you use the identical macro with the parameters sine d and 60, the macro will evaluate the sine in 60 degrees. So it shows you the flexibility that's behind this command language, and there are a few places where things like that make sense, but most of the time, if you encounter a macro like that, it's impossible to know what was the intent of the user, so be very careful. Use plenty of comments in order to describe what is really the idea behind this. What do you want to do? All right, time for a little extra homework. So again, we want to now change the previous macro, make a new macro. We just want to create it somehow. A macro that takes one parameter, an integer number n, and then it shall calculate the factorial product 1 times 2 times 3 times etc. until n, and shall store this into a variable and evaluate the actual final value of this variable. So again, I will pause this clip here and give you a little time, invite you to stop this, interrupt this, to think about how do I do this, how do I work it out, and I'll be back in a minute. And I know you cheated, you didn't do it yourself, so we can either edit the previous macro. Let me do here a new one with a learn process. So I simply type learn factorial.mac, for example. And now we say we need a variable integer, comma, number. And it doesn't matter that I redefine the variable integer. The program will recognize we had used this before, so that's fine. And now we want to do a factorial up to a value of n. That's best done with a loop, since DISCUS actually does not have a factorial function built into. So simply let's say we want to have a variable integer, comma, start, a variable integer, comma, finish. And now there is actually a built-in variable, loop in capital letters, so you don't have to type this to use. What I will do is we will say here start is equal to 1, and then we need our number is equal 1, and then the finish is equal to, and now I need to type a number, go into the macro, edit that. Since the $1 here would not be interpreted, let me quickly test type it 2. And now I can type here do loop in capital letters, that's a predefined variable, loop equal start, comma, finish. And in this loop, we now need to do number is equal to number times our current loop index, and do and evaluate the number. And now we end the learning process, end. And in order to work flexibly, I quickly need to edit this new macro that I have here, the factorial macro. So I open it in the notepad here. Just looking for the font size to increase. Don't find it here right now. In the next macros, I'll do that previously. Excuse me. So it's a little small here. So what I need to do is, instead of here setting the finish to 2, I need to change that to $1. We only want to have one variable. And now the macro will be flexible. Save it. And if I now run this as at factorial, let's try it out with a 2. Of course, we get here to 2. If we calculate the factorial of 5, as we had done previously in the fixed macro, well, now we get 120, and so on. You would get eventually the factorial of these numbers. So let me type it here. Such a macro basically has all the variables defined typically in the beginning section of the macro. We define here the starting value. We define an initial condition for the number, and then assign the value of the string $1 to our finish variable. And then here in this loop, we go with the built-in variable capital letters loop from start to finish, and multiply our number by the current value of loop and place that result into the variable number. Notice I don't have to indent these lines. It's helpful if we do here in the macro. If we indent these lines a little bit, makes it easier to read, to see that this block from the do to the end do is a simple block. But it's not important, unlike Python, where the indentation is critical to the macro or to the script that you write. All right. If you now look here for the cheat, you see basically the same concept. We have a variable called product. There I call it number, a counter index loop, a start and finish variables. We initialize our product, since we can keep multiplying the product here with a value, so it needs to be a value of initial value of 1. And then we have the start and the finish here, $1, that takes flexible value. And in this loop, from start to finish, we keep multiplying product with the loop index, which will then go up from 1, 2, 3, 4, 5 to our final value, and then we evaluate these data here. There are, not that commonly used, also a couple of character functions in there. For example, the function date in round brackets 0 gives you the current date. Here in this format, century, year, month, date, and the hours and minutes. fdate does it similar, but in a form day, month, date of, the date of the week, the month, and the numerical value of the day, the hour, and then here the century. There's also here something called getCWD, the get current working directory, in order to be knowing which current variable, current directory we're in. So for example, if we say here variable character, comma, let's call it string, we can place into the string, we can simply say string is equal to, and now I need to quickly do here little trick that I'll explain in a second. So what do I do here? I want to type into string the result of this fdate function, and these double exclamation marks allow you to use very flexible programming, very flexible formatting into the string. The %c stands for a character string of variable length. So if we do here this echo, typing here echo, likewise %c of the string, we get the date at which this clip was recorded, Monday, May 4th at 5 o'clock p.m. And that is possible to use these dates. I will use another clip to explain the more details of this formatting. Right now, just know that you can look up in the help menu different things here. For example, we could echo the current working directory, so we know we're in this working directory and can manipulate that and work around with that. You can use the length of a string, the index of a substring inside another string, a little more detailed things. And the rest here, there are two special functions called isVariable to test, is this string a variable, and isExpression, is this a valid expression? For example, if you want to make sure that a macro does not divide by 0, you can test here if this expression is valid, if you don't divide by 0, and then do something else, print out a error message. As I mentioned, these are details, and I'll keep explaining those in the macros in the clips to come. All right, this is the end of this clip. It has given you an introduction to the syntax. I know it may seem a bit more complex than a regular graphical user interface, but as you will see in the macros to come, this allows me to use very flexible building concepts to build a crystal with eventually infinite size using periodic boundary conditions, to build a perfect crystal, to build a crystal with all sorts of defects inside, to build a nanoparticle of essentially arbitrary shape, a spherical nanoparticle, an ellipsoidal nanoparticle, or a nanoparticle terminated by certain crystal faces, decorate the nanoparticle on the surface. And all this flexibility comes a little bit with a price, and the price is this command language that you have to get used to. Again, you will find a lot of examples in all the macros here in my lectures. So have a look at these macros. They are commented, most of them quite extensively, explaining the different commands in these lectures to show you what are they for. And I will now eventually go through more and more of these sections of the lectures to explain how you can build a little nanoparticle. How can you build a crystal with this order in there? And as we do that, you will see more and more of the macro language explained, and eventually this macro language will become very common to you. And I hope this will be helpful. I thank you for your patience, and I look forward to seeing you here on the DISCUS channel in the near future again.